This video will discuss the basics of using the script command line in ConcreteBending. Let's get started. The script feature in ConcreteBending is a powerful tool that uses a command line interface to create model objects, generate service cases, apply loads, extract results, generate reports, and more. We will use the command line in this example to create a simple concrete pavilion. All the commands that are available for ConcreteBending are listed in the commands page of the help file. The help file also provides a written overview of the command line basics. The script tool is accessed by clicking the script tab at the bottom of the Find tool. Note that inputs and outputs in the command line are always in the current unit style. For this example, let's set the unit style to kips and feet. From the command line, we can add a rectangular boundary to the model using the Add Rectangular Boundary command and entering the X and Y coordinates for the center of the boundary and specifying the width and height of the boundary. Note, to look up a command, we can enter its name inside quotes in the help command. This launches the help file and takes us to that particular command to see the various inputs it can receive, a description of what the command does, an example of how it is used, and an explanation of the example. In the help file, we see that there are commands to add rectangular, circular, and polygon boundaries, in addition to an add boundary command to generate a generic boundary based on a list of the X and Y coordinates or based on an array of locations. Next, let's define some variables to store the parameters for generating the point supports. Variables circumvent the need to input the same number over and over again. Note, when storing a value in a variable, the line must end with a semicolon. We can add a point support by specifying its X and Y coordinate, or we can add a point support by using a location. Locations are particularly useful when we want to define items in a model so that they coincide perfectly with one another. For example, we can define a beam using the same locations that we used to define two of the point supports. If we end up changing our minds and want the beam to extend past the point supports, we can move the start point and end point of the beam in the command line as well. Note, when using the name of model items in a command, bx001 in this example, it must be enclosed in quotes. Keep in mind that we can always switch back and forth between using the command line and driving the program in the traditional manner with the keyboard and mouse. In addition to using the various commands that are built into ConcreteBending, any valid C# code can be used in the command line. For example, we might want to add a parabolic boundary to the project, which would prove to be challenging to draw by hand. To create this boundary, we can define a function for y in terms of x. Next, we can create variables to store the list of the x coordinates and y coordinates. Then we can use a for loop that starts at x equals -12 feet and ends at x equals 12 feet, and is incremented by 0.25 feet to populate the list of the x coordinates and the y coordinates using our function. Finally, we can add a boundary to the project that is defined by the list of x and y coordinates that we created. For convenience, the up and down arrows on the keyboard are used to auto-populate the command line with previously entered values. These values can easily be adjusted to create another parabolic boundary at a different location that we will set as a whole using the toggle hole command. Next, we might decide that we need to shift the point supports and the beams upward in our model. We can easily accomplish this by creating a list of the point supports and of the beams in the model. We can then use a couple of for each loops to move all of the point supports and to move both of the beams in the model. Having created the model objects for the concrete pavilion, let's work on applying loads to the model. Let's use the load full boundary command to apply a uniform pressure to the entire boundary in the current service case. We can also use this command to apply a linearly varying pressure in a specified service case. In addition to loading the full boundary, there are several different commands available to apply various loads to boundaries, and there are additional commands that can be used to apply point loads and beam loads to the model as shown in the help file. In addition to creating model objects, the script command line can be used to extract analysis results, including the displacements, shears, and moments in the concrete plate elements. For example, we can use the moment_x command with the fall spool to return the largest negative moment across all the load cases. We can use this same command to return the largest negative moment for a specified result case. And furthermore, we can specify the location in this command from where we want to extract the result in the model. At any point, we can enter clear into the command line and press enter to clear the script and reset all of the stored variables. In this video, we've used some built-in commands and basic programming to create and load a concrete pavilion and extract analysis results. More advanced programming can be performed in external scripts that are read into the program as discussed in the external scripts training video. Thanks for watching and have a great day.